All this axis, no? So just for our consideration, so these are the centers about which the axis will pass through center, that one. Now, what will happen here now? This having velocity VA like this. This having velocity, so VA, and what about the velocity of this? VB, and the velocity of this VB, and this is VC. This what happens, no? Velocity of these points we are taking it. We'll do one thing. We'll take 1, 2, 3, 4. Velocity, this is V1. We'll give name V3, and this V4. And tell me in what direction the friction should act on the disk A. Friction should oppose relative motion. V1 is like this. V12 in what direction? V12 will be upward. So the friction on this disk will be acting in this direction. I'll call this friction as F12. Similarly, what is velocity of point 2 with respect to 1? V21 downward. So the friction on this should act in this direction, F21. In fact, F12 is equal to F21. Similarly, velocity of 3 with respect to 4 will be upward. So the friction here should act like this. So F34. And the magnitudes F34 equal to F43. Okay, this much is there. What this friction F12 will do? Will decrease the linear velocity of 1. And what this F21 will decrease linear velocity of this one. And finally, what pen? Find the angular velocity of cylinders after they stop slipping. Tell me finally what should happen now? You can expect such questions in exam. It's very simple. I'll definitely, as a teacher, no, I do prefer to ask such questions, in fact. Because nothing big we are going to use here. You can see no integration, nothing is there. Okay, let me adjust the diagram. Finally, no slipping is telling. Some rough diagram I have put it. Finally, no slipping means what do you expect? What should happen? Finally, I'll suggest like this. Sir, how you can make such a thing? Initially, all were having same angular velocity. Finally, what happened? These are the velocities of the disk A, B, C. They should not be slipping, no? So finally, what happened? The velocity of 1 should be equal to velocity of 2. In what direction? Both must have same velocity. And these 2 points, 3 and 4, they must have same velocity. Then only no slipping. Then only no slipping idea will come, no? They must have all, since all are having same radius, identical. So I'm going to put same velocity v. Then only no slipping occurs here. Okay, what is our question? Find the angular velocity of cylinders after they stop sliding. Will they have same angular velocity, different angular velocity? I think you look at that one. Velocity of 1 should be equal to velocity of 2, and they're having same radius. The radii is same. So if you look at this, from here, v equal to what you can write? R omega at point 1. Velocity of point 1 velocity of point 2. This is also equal to, okay, no. Velocity of point 1 is v. That also v. What is v? R omega a, r omega b. So therefore, omega a equal to omega b. Similarly, magnitudes. Similarly, velocity of point 3 is equal to velocity of point 4. So therefore, what will happen? Omega b should be equal to omega c. Velocity of point 3 should be equal to, so therefore what is the conclusion we can make it? Omega a equal to omega b equal to omega c. Modulus, not sign, it's about the modulus. Okay, now finish over. After this, it's asking how much that magnitude, how to find out. I'll apply angular impulse, angular momentum equation, because I think that's the only thing which is available, which is going to help us a lot. What is angular impulse, angular momentum equation? Now, let me take this one. What was the initial angular velocity? It was omega, no? And finally, it has become omega a. And is there any angular impulse acted? Yes, the friction. So if these frictions also, will they be equal? Will they be equal? Let's see that. I think I'll show complete numerical. Yeah, let's write equations now. Initially for the disk A, I omega minus F1 to R delta T should be equal to I omega A. This is for disk A. Now similarly for disk B, you write it. Disk B, what happened? What was the initial angular momentum of that? Anti-clockwise. Anti-clockwise. And how the torque acted? F1 2 only, I'll write it. Should be equal to, and finally it has acquired opposite to that one, minus I omega B. Similarly for disk 3, we'll write it. Is that sign okay? I omega. No, for the disk C, I omega. In what direction the torque is acting on it? Anti-clockwise, minus F43. What is the direction of it? Okay, yeah, didn't change. Okay, we have this much. What to do after this? And F12 is equal to, okay, no, I'll take care of that one. Huh? I didn't see that. For this B, let me do correction. So initial I omega minus F12 R delta T minus F34 R delta T. Try to see once. This torque F21 into R and F34 into R, both will set up anti-clockwise torque. Initial angular momentum was anti-clockwise. The angular impulse was clockwise. So initial angular momentum is what? I'm taking positive. And finally what happened? It will have the clockwise angular momentum. Look at this one. So I do have. So we know F12 is equal to F21 and F34 equal to F43. So what earlier I wrote, okay, let me write symbol. This will be much easier. So three equations are there. Adding all these three equations and omega equal to omega b equal to omega c. So let it be equal to say some omega naught, I'll write it. Let me slide down. No. Shall we add up all these three equations? 1, 2, 3. Adding up this, I omega is equal to I omega plus omega b plus omega c. So this should be equal to, say I did all calculations, check once. So what is omega naught? Is omega by 3. This would be final angular momentum. Okay, now is it angular momentum of individual disk is conserved? No, there the angular impulse is acting. No, so therefore angular momentum of none of the disk is conserved. In books you have 2 disks. I just brought for 3 disks here. You can apply for any number of disks, no problem. So what is the next part? Can you use principle of conservation of angular momentum to analyze the situation? Answer is no, because on each and every disk there is an angular impulse is acting. So therefore the answer will be no. Now what is the final answer? Omega A will be anti-clockwise, omega B will be clockwise, omega C will be anti-clockwise. This will be our final answers. In exams can be asked, you have to be very alert with such small numericals. I'll scroll down, see once. Come for